Hey there, calculus fans. I'm teaching a business and econ class that has some calculus in it. And today I've encountered errors in distributions, I think 4 times. And somebody's asking me about it in an email. And this is a common problem. It's not just for this course, it's in all my courses. And it boils down to this understanding of arithmetic. And I've never thought, why don't I just stop for a moment and talk about this? So the question I got emailed specifically, and then I'll talk about some of the other issues, was about this solutions. We're doing derivatives. And basically the question was, take the derivative of this, and I've talked about this a lot in class about how you pull out the coefficients, how you rewrite the powers, how you use the product rule. And the student, I think, didn't have a problem with any of that, but they did have a problem with this, which highlights an important thing. They said, how in the world are you allowed to distribute the 1/2 only to the 2? That was their question. How can you only distribute here? Why didn't you distribute in here? Or why didn't you distribute it to the x? That was the question. And that highlights this thing I'm going to do. So we'll come back to that in a second. I do like to emphasize to students that no matter what is happening, you can always go back to arithmetic. And you can use your brain, meaning you can compute it yourself. I don't mean that negatively. It's just in the middle of a bigger problem, it's easy to make these mistakes. So let's do a couple things. So if you were sitting in front of me, I would say, what are those 4 numbers? And I hope you would know. When you're doing arithmetic that just involves one operation, we just go left to right. So you would say 5 plus 1, this is 6. And I wouldn't move forward until we all agreed that that was 6. This is 3 minus 2, which is 1, minus 1, which is 0. So let's kind of make some notes. We think this is 6. We think this is 0. And I'm kind of surprised sometimes the students aren't even confident in that. We got to build this confidence. 3 times 2 times 1, that's 6. 2 times 1 over 3, that's 2/3. Okay, so I want to talk about each one of those, and really there's a lot of information here just in terms of distributing. And I don't teach this all the time. I mean, this is more kind of a thing you would do in elementary, middle schools, but there's this misconception that seems to persist all the way through college, and I want to deal with it. Okay, so imagine we change the problem a little bit and we put parentheses. And just bear with me. We'll be able to accelerate pretty quickly, but let's throw some random parentheses in here and talk about this, because this immediately gets to the issue I have seen cause students problems over and over again. It's not everybody, it's a small percentage, but it's sizable enough to indicate a bigger thing, and it's not a thing that to like embarrass anyone by. It's just like, hey, we can remedy this. So what I've seen over the years is a discomfort in those situations. So I would like you to think before I move on, which one of those has changed from the original value we had and which one is the same. And I hope you see that this is the same. These two things are the same. In this situation, the parentheses are just dumb. You shouldn't have them. These two are the same. You should see that because it's just 3 times 2. But I have seen many errors in both those situations. I've seen students distribute this many times. Calculus, high-level calculus classes. I've seen students distribute and tell me that is 5 plus 4 is 9. I've had students tell me that 3 plus 2 plus 1 is 9, and they don't see a problem with it. So that's a problem where you should not be distributing if all it is addition. This is the one that I see all the time. I see this distribution of 3 times 2 and 3 times 1. So I'll see a student do 3 times 2 and 3 times 1. And they'll say 3 times 2 times 1 is, what would that be? 18. That's not right. So what can we take away from those two problems? When all you're doing is a bunch of multiplication, there is no need for parentheses. You can put them in, but they do not change things, and you do not distribute. So addition, we'll make some notes for yourself. Addition only. And you don't have to memorize something like this. You can just do the same experiment we did. No distribution. And at any time, again, you could just run an experiment with numbers. Multiplication, only in a problem, no distribution. Okay, so that's number one. And that means when you're doing multiplication or addition, you can rearrange any way you like. And that bothers students for some reason. They don't have this freedom. You need to free your mind. If somebody gives me 1/2 times 3 times 2 times 4, I immediately say 12. I find in my experience a lot of students will get a calculator out. And they'll do, 1/2 times 3 is 1.5, times 2 is 3, times 4 is 12. That doesn't make any sense to me. I had a student the other day say they were taught something called, their instructor called the telephone method, which I thought was awesome. To say something kind of basic. Look, it's a telephone. You can always multiply. If all it is multiplication, you can multiply using your telephone. It's just called commuting. And you should eventually get to where you can do that in your head, but you do not distribute. We're just reordering, and the order doesn't matter, and 2 times 1/2 is 1. We need that skill. It needs to be just part of our DNA if we're going to work our way through higher level math courses. The same thing happens over here for the division. I've seen this messed up many times, and I've seen students write 2/3 times 1/3. And that's wrong. That's 2/9, and it's not the same. If all you're doing is a bunch of multiplication and division, I like to tell students just to pretend it's all multiplication. 1/3 times, I don't usually write this. And then the moment you're here, you're like, oh, it's all multiplication. Those parentheses are worthless. They were unnecessary. Okay. So if all you're dealing with is a bunch of multiplication or division or addition, and they're just by themselves, that's what you do. Now, I stopped over here because subtraction, the order matters. Division, also the order matters, but if it's written like a fraction like this, like it usually is, that's another video. I could talk about fractions. There's the errors I've seen with fractions for a long time, but I want to focus on distribution in this video. This is different because this is 2. And so this serves a different purpose. Subtraction doesn't commute. You have to go from left to right, but you still don't distribute. So we have not seen distribution yet on this page, is the point I want to make. There is no distribution happening anywhere here in any of these situations. No distribution. So imagine, for example, you have 3 plus x plus 1. Do we distribute? No, it's all addition. Doesn't matter that there's an x there. We don't distribute. We just drop the parentheses. So if it's all addition, I'm going to say this a few different times, so I really want to hammer this home. You say, oh, it's all addition. I'm going to drop the parentheses, and I'm going to write 4 plus x. Or if you have 2 times x times 4 times x, and there's parentheses here, you're not going to distribute at all. You're going to drop the parentheses. You're going to do 2 times x times 4, and then you're going to rearrange however you want. You can use the telephone method. It's going to be 8x squared. That's what we're going to do. Notice I never thought about distribution. So do we ever distribute? Very rarely is the point of this story. You almost never distribute. That should be your mentality. Your mentality shouldn't be, I see parentheses, I distribute. Your mentality should be, I am going to almost never distribute. This goes back to this original problem, which is I just rearranged my multiplication. I had 1/2 times this mess. Let's just for a moment, let's just call this mess times 2 times x. That is identical to this example here. Except instead of a 4, there's an x. Instead of a mess, there's a 3. But it's all just multiplication. And so you don't distribute. Don't distribute, don't distribute, don't distribute. You'll get the wrong answer. And at any point you encounter something like this, you could run an experiment. 1/2 times 10 times 2. Put parentheses here. And you could say, okay, that has to be 20 over 2. So it has to be 10. And you could say, but I'm unsure if I should distribute. And so you run a quick experiment and you say, hold on, that's only 5. Oh, that can't be right. Oh yeah, Dr. Lovelace said, you shouldn't have parentheses at all if all you're doing is multiplication. All right, very important idea that I think people just they don't encounter it enough and they just get problems wrong and they don't know why. And so we really need that. We can't move forward if things like that are bugging us. Okay, so now let's talk about when we distribute. And I should extend this to another situation, but there's so many little things to say here. Today, somebody was asking me a question on my discussion board. They were doing this, except it had variables, and they said that this was 2 squared plus 3 squared. That's part of what's called the sophomore's dream. There's certain things that we encounter a lot. Here's another example of the sophomore's dream. Normally the numbers we use is 3 squared plus 4 squared, and I've seen students do this. These are both wrong. And it's yet another example of distributing when you can't distribute. Those are not the same. You can just quickly check them. This should be the square root of 25. Which is 5. Whereas this thing over here is 7. 5 is not 7. This here should be 25, but the thing over here is 13. 13 is not 25. We do not distribute there. So I'm making this case that we never, ever, ever distribute. And that would include this situation. We can't distribute this 1/2 because there's this negative 1/2 here. So your thought should be, I am never going to distribute. Don't be casual with distribution. So why do we even have the word distribution? It's when you're mixing multiplication and addition. You can extend that to a situation where there's subtraction involved. So it's only in a situation where you have addition or subtraction mixed with multiplication and division. Multiplication or division. So let me give you several examples where you do distribute. So let's take 3 times 2 plus 1. Notice we have mixed operations. We have a times here and we have a plus here. Those are the only situations, and there's no exponent here. There's nothing else going on. The only things, and nothing else. Okay, that's it. And at any point, you can always just plug in numbers and experiment. So here, let's run our experiment. This is going to be 3 times 3, which is 9. If we did want to get the same number, you can do 3 times 2 plus 3 times 1, which is 6 plus 3, which is 9. That always works. But we should be skeptical because we've seen that hasn't worked so much. You should be skeptical of distribution. But there it works. Okay. Then I had a temptation to prove it there, but that won't resonate well with my students. So again, if you have 3 times 2 times 1 and there's parentheses, you say, oh wait, that's all multiplication. Don't distribute. It's just 3 times 1, which is 6. Cool. It extends to if there's a variable. What if you have x times 3 plus x? We are mixing operations. We should distribute. And that's going to become 3x plus x squared. All right. So what if, let me think if I can think of anything else. What if we have 3 times 2 times x. Do we distribute? No, it's all multiplication. The parentheses shouldn't have even been written. It was just dumb of me to write them, but it's okay to write them. That should just be 6x. Okay, maybe one other thing as I'm thinking of it, and then I'm sure the video is already way too long, and the people who I'm trying to help didn't make it this far. If you watch the video this far, tell me in the comments that you're still awake. That's the problem. The other problem is the people that need this information never can stay awake long enough to listen to it. And then you say, well, it's because you're such a boring old man. And I say, you're exactly right. Okay, so the other situation would be something like this. 3 plus 2 over 5. This is another situation where we're actually mixing multiplication and addition. You say, what? That's not multiplication. It is multiplication if you look at it this way. You can distribute here. Now, because I know that, I would just have distributed right away. You can also just think about that as adding fractions. I like to think of things forward, backwards, and in different ways so that I have more than one connection. And so whenever I do a simplification, I go, can I go back? That's a distribution. And it's a distribution because it's a combination of multiplication and division and addition or subtraction. So if it had been 3 minus 2 over 5, you can also do the same thing. 3 over 5 minus 2 over 5. That's it. So the short answer to this, as I think about this, I've never really thought about this but in my classes, by the time you're there, this needs to be an 8. But as I think about presenting this to students where maybe they don't have as much background here, the presentation is never, ever, ever distribute except if you have multiplication and division right next to each other and nothing else is happening. Okay? That's it. One other thing I'm thinking of that happened in office hours, if you have 5 plus 2 times 1 plus 3, everything happens with multiplication first. There is an order of operations. I've seen a bunch of students in office hours call this 7. And unfortunately, it doesn't work that way. Multiplication comes first after you do the parentheses. So what this should be is 4 here. This should be 2. This should be 5. And it's going to be 5 plus 8, which is 13. Now we could have distributed, that would have been legal. That's a mixture of addition and multiplication. That would have given us the same answer. It would have been 5 plus 2 plus 6, which is 13. So there you go. That's just a side piece there. This is stuff that you're doing in every single homework question. So when you encounter something like this and you're like, I thought it would be this, you need to stop. You need to raise an alarm, which I'm really glad the student asked me this question, and then ask me. You can see that I am willing to dig deep into the math of first, second, third grade, wherever this popped up, because it's not that you don't know it, it's just that it's popping up in a way you aren't expecting, and we've got to clear that up now, and then you can be successful moving forward. Hope that makes sense. I have other things to say, but let's stop.